So if you guys would, let's get our packet out. Let's get our notes out. Again, you can use this on Thursday's test. Okay, so we got radical equations. Last section, guys. Last section. So if we take a look, it says solve radical equations. We might have square roots, cube roots, fourth roots. Okay. And when I look at example 1, I have the square root of x is equal to 5. Well, do you guys know how to get rid of square roots? Any ideas? People at home, use your microphone or your chat. People in class, use your voice. How do we get rid of a square root? Any ideas? Calculator. Da-dunch. Any ideas how to get rid of a square root? How do you get rid of division? Multiplication. How do you get rid of subtraction? Addition. And to get rid of square roots, we square it. When you square a square root, you get what's inside. 5 squared is 25. Okay? Now, I always like to check these. Check it. I like to plug those in. So I plug in 25 for x. So I plug that into the original. Is the square root of 25 5?
Yes.
It checks out. So it is for sure the answer. Okay.
25.
All right, so I'm going to look at number 2. I have a fourth root. All right, so I have the fourth root of x is equal to 3. So now what? How do I get rid of a fourth root? Any ideas? Well, to get rid of a square root, we square both sides. What do you think we do to get rid of a fourth root?
Root it by 4.
And we do the fourth power to each side. So when I take a fourth root and I raise it to the fourth power, I get what's inside. And then over here, I get 3 to the fourth. 81. 3 to the fourth is 81. Okay. And then we can check that. So we have the fourth root. It's 3. And if I plug in 81, you can plug that in your calculator in the math menu, or break that down, 9 and 9, 3 and 3. We have 4 of a kind right there. You can't see it?
I can't reach that.
So final answer is 3. Okay.
Oh, we know, sorry, we're not showing the fun side.
Again, do you have to check it? No, but I recommend it. It's always a good idea. Okay. So as I take a look at number 3, I have the square root of x minus 12 is equal to 8. Right? So what we want to do is isolate the square root. We want to get the square root by itself. So isolate the square root, which means get the square root by itself.
You add 12.
So we're going to get this 12 on the other side by addition. So we get the square root of x is equal to 8 plus 12 is 20. And then how do we get rid of square roots?
Times 2, or times.
We square it. So we end up with x equals, and then 20 squared, 20 times 20? 400. 400. And if you want to plug that in, you can. Either plug it into the original, and it does work out. Okay. Do you guys have any questions there? Is that equal to 0 on this one? Do you guys have that?
Yes.
I'm going to rewrite this one so you guys can see it nice and pretty. All right, so again, the same idea. Number 4, I want to isolate that square root. I got a couple different ways to do this. Any suggestions? How do we get the square root by itself? You can subtract the 5 and then divide over. You could also add the square root of 3x over. It's kind of your choice. I heard subtract 5. So 5 minus 5 will cancel. So we get negative square root of 3x is equal to negative 5. Well, I still have this negative in the way, so how do I get rid of that negative?
Divide by -1.
Divide by -1.
Which makes it
Basically
1.
changes the signs, right? So now we have the square root of 3x is equal to 5. And now we've isolated our square root. I can't divide that 3 over. The idea is whatever's inside of that square root can't be touched. All right, so we just got to get rid of that square root. So we square both sides. Okay, so when I square the square root, I get what's inside. I'm going to write that over here. So I got 3x, and then 5 squared is 25. And then my last step, divide by 3. So I do get 25 over 3. My math lab will probably say, give me the exact value. Okay, so that does not reduce at all. I would just give it 25 over 3 reduced if you can. This one doesn't reduce though.
Oh.
Okay. Okay. All right. Any questions on that one? Now, at any time I want to check that, I can throw that in there. Right? I can check it. 25 over 3 times 3. The 3's would cancel. And I would get the square root of 25 in there. Well, the square root of 25 is 5. And 5 minus 5 is 0. So it works out perfect. Okay. All right. Questions? So when I look at example 5, what do you guys notice in example 5? What do you guys notice?
It has an inside.
We have the accent, we have it isolated already.
No, wait. Yeah.
Okay. Now I want you to think about this before we're gonna come back to this idea. What's the square root of 100? What's the square root of 100? 10. What's the square root of 49? 7. What's the square root of 121? 11. Okay. Notice you're always getting positive numbers there. Well, if I try to solve example 5 and I square both sides, okay, it's already isolated. I'm ready to go. I've got 3x plus 2 and negative 7 squared. Negative 7 times negative 7 is positive 49, right? And then we solve. We subtract the 2 over. We get 3x is equal to what, 47?
Mm-hmm.
And when divide by 3, that doesn't reduce at all, right? We get x equals 47 over 3. Now take a look when I check this guy. When I check it, I'm taking 3 times x plus 2, and I'm seeing if that's equal to negative 7. If I plug in that 47 over 3, right, the 3's are going to cancel. I get 47 plus 2 on the inside. What's 47 plus 2? 49. Is the square root of 49 equal to negative 7? What do you think? Plug it in. What's the square root of 49? Just 7. Okay, so the square root of 49 is not negative 7, it's positive 7. So anytime you guys see this on homework, anytime you have a square root by itself equal a negative number, then you can go right away and say, no solution. 47 over 3 does not work out. The answer is the empty set, the null set. We'll circle with the slash through it. It's no solution. So again, anytime you see a square root equal a negative number, you've isolated the square root and everything on the right side is negative, no solution. Okay, this was one of those examples where it doesn't work out. Okay, so really, did we need to do all this work?
Not really.
No, if you know the little trick, square root equal negative, no solution. All right, any questions, y'all?
We don't need a solution.
All right, let's take a look at number 6. Number 6, I've got the square root of 2x plus 9. On the outside, I have minus 4 and then equals 6. Can I combine this 9 and the negative 4? No. One's on the inside, one's on the outside. So everything on the inside cannot be touched. Okay? Hands off. Right? It's like a present at Christmas. You can't get that inside until you open it up. Only way to open up a square root is square both sides. Yeah, we're going to add this 4 over. So now I've got the square root isolated. I got the square root of 2x plus 9. 6 plus 4 we know is 10. Now I can get rid of that square root by squaring. Okay, so when I square both sides, I get 2x plus 9 is equal to 10 squared, which we all know is a hundo. 100. And now it's just basic algebra. You guys know how to solve this. What do we do?
Minus 9.
Subtract the 9.
This one's minus.
I get 91, right? Divide by 2. And 91 divided by 2 is either, what, 45.5? Or
35.5.
if they want the exact value, it'd be 9 over 2. If they're okay with 45.5, then I'm okay with that. You just got to see what my math lab, usually it's in blue, what my math lab wants. Okay, so 45.5 or 91 over 2 is fine with me. If it reduces, you should reduce. And if it doesn't, then that's it. That's easy peasy. You guys want one more?
Yes.
Yeah, for sure. This last one looks scary, doesn't it? If we follow the rule, though, the rule is isolate your square root. So right now I've got both things on the same side, so I need to move one of these guys over. Which one do you want to move over? Yeah, this minus 3 root x, we can move that over using addition. So positive, add it, plus 3 root x over. So what I've got now is I've got the square root of 3x minus 5, and that equals 3 root x. So far, so good. All right, so we've isolated the square root, so we're ready to go. We're going to square both sides. Okay. When you square the square root, we get what's inside. We get 3x minus 5. Okay. Now this one, this idea, okay, you can look at this 2 different ways. You can look at this as 3 root x times itself. That's one way to look at it. Okay. When you take 3 root x times itself, you basically multiply the 2 guys in front. What's 3 times 3? 9er. And then you take root x times root x. What's root x times root x? What's the square root of x times the square root of x? What's the square root of 7 times the square root of 7? What's the, yep, we just get x. Okay, so here's another way to look at this. Or you have 3 root x, and when you square it, you square the number in front, and then you square the square root. So you take 3 and you square it, that's 9, and when you square the square root, you get what's inside, which is x. So, bless you, you got 2 different ways to look at that. Whether you're like writing it twice and then multiplying numbers on the outside, numbers on the inside together, or just square the number in front and square the square root.
I think I like that.
That's what I usually look at. I square the number in front and I square the square root. And now it's just algebra. You guys know how to do this. Get the x's on the same side. Subtract the 3x over. We get negative 5 is equal to 9x minus 3x is what, 6x? And then we divide by 6.
So we got x equals
I get negative 5/6. Okay. Now, before you plug that into my math lab, we should always reduce it, and then we should always check it. Okay? Check it. When I plug this in, whether I plug it in here or would I plug it in here, let's say I plug it into this part here. All right, so I've got the square root of 3x minus 5 minus 3, the square root of x equals 0. When I plug in this negative 5/6, this becomes a problem. Okay? If you take your calculator and you do a square root of a negative, you get an error message. Okay? So I'll show you what happens when you do that. If I do the square root of any negative number, square root of negative 5 divided by 6, I get no real answer. So guess what that is? This is no real solution, no solution in the real world. Empty set, null set. So again, check it. Two things you want to be aware of. When you get an answer, especially if it's negative, if you plug it back in, does it make the square root negative? If it does, it's what we call an extraneous solution. It means it's no solution. Okay? Or if you're solving and you've isolated the square root and it's equal to a negative number, no solution. That's not going to be possible. Okay? This one only happens, guys, usually is when you have two square roots and an x underneath on both of them. Usually that's the only time you'll see that. Okay, so just be very careful. When you see two x's underneath square roots, there's a chance it could be a no solution one. Okay? Guys, that's all I got. That is really a segue into, well, if it's no real solution, then what is it? And that's what 10.7 is all about. And we're not learning 10.7 until after spring break. 10.7 is going to be its own little thing. Okay? That way it doesn't confuse anybody. So, ladies and gentlemen, that is it. That is solving just basic radical equations for y'all. Do you guys have any questions for me?